Hello coders, welcome to my video. So in this video we'll discuss the following points. So the first point is what is structure padding, then why this structure padding is required, where to use the structure padding and where not to use the structure padding, and inspired we're using the packed structure. So what are packed structure and where it is used. So let's start with the first point. What is structure padding? So compiler add the padding to the data to make the processing fast. Each member is aligned to its natural boundary. Structure size become multiple of the large member alignment. Okay. So what do you mean by that? So let's take a structure to so we have struct A, okay, and here I'll put char C, okay, and I have int I. Okay. So what's the size of this structure? We have to get this first. Okay. So let's print the size of the structure. So we have printer, then we have size of the struct A is equal to we have percentage uh z- okay, and now what I will do, I'll use a size of operator to get the size of the structure, and we have struct A. Okay, so let's compile it first. We check. So we have structure C, and when I try to run it, I get 8. Okay, so if I individually get the size of int and size of car, okay, so comma, or I'll do here size of int is equal to percentage e. Okay, and here I will print. So this is okay. So I need to get zu, get unsigned value of this. Okay, so size of int is 4. So if you calculate the size of char is 1 byte and size of int is 4 bytes. So total is 5 bytes, okay, for this structure. But due to this structure padding, I'm getting the value as 8. So why this 8 I'm getting? This is due to the structure will take the padding according to the largest member in the group. Okay, for example, I have int I. So the largest entity to take here is 4 bytes. So multiple of 4 bytes will be there to adjust the structure padding so that compiler can process the structure fast. Okay. So what it will do, it will take 4 bytes for this and it will adjust this character in the 4 bytes. So total will be 8 bytes. So what if I can take one double k here, okay, and I will also print the size of double as well. So double is equal to comma percentage u, and here I've got the size of double, size of, so that you can easily get a context for this compiler. What is the value? So 8 for double, 4 for int, and total is 16 now. So the largest member in this structure is double, it is of 8 bytes. So we are checking if these two values is easily adjusted in 8 bytes. So it will give you 8 plus 8 is 16 bytes. Okay. So next is if we reorder it, will it make a difference? So if I put this after this, will it work or is there any optimization done by the compiler for reading this structure? So no, the structure is 16 only. Okay. So what if I remove this character C? So at this time, will I get some new thing? No, it's already 16 only. Because if I change this to char, let's say the char I will put here. Now, this is taking 8 bytes and this is only 1 byte. So is that adjusted in 4 bytes or it is adjusted in 8 bytes to prove our context? Okay. So if I compile it again and if I run it, you will get 16 only. Oh, okay. Only a single byte, but the box of 8 bytes is taken. So what if I take this k as int now? Largest byte now is int. Okay, so it will be somewhere around 8 bytes now. See, we have 8 bytes now. Okay. So what if I take multiple of char? Okay. So I'll remove this and I will take C1. First, I'll take this. Let's see the size of the structure now. So 3 bytes only. So there, the largest element here is character only. So that's why the structure size is not altered. Okay. So now I think you get the context. So if I increase one more and now 4 and again I'll take 5 now. So will the structure be 5 bytes or any other? Okay, 5 bytes only. So this proves our context that the structure will take the largest element within it and adjust it. So one more example. So what I will do, I'll take a nested structure example. So I have struct A1 and here I will be getting, for example, int I and char y or something. Okay, anything. And here what I will do, I'll take C4 only and here I will adjust my struct A1. Okay, so now if I calculate what is the value of structure, it's 12 bytes. How it is 12 bytes now? So this is 8 bytes as we have integer, so it is aligned to integer byte. So we have 8 bytes for this. And if I put it here, the largest element in this whole structure is integer. Okay. So in spite of having this structure as 8 bytes, it will adjust to the maximum integer here only. Okay. So that's why the value is shown as 12. Okay. So if I put it to double, Now the largest element here is double 8 bytes. Okay. So here we have 8 at 16, 16 for this structure A1 and 8 for this. Let's see, 24. Correct. Right. So this is how, if I put these values directly in spite of the structure, so the point here was, so this structure padding is done on the structure level and this structure padding is done as a whole. Okay. So if we want to adjust, we can copy these two values here to decrease the padding. Okay. So this is how our structure padding works. Okay. So now I have 8 bytes for this structure. Now, if I don't want the compiler to adjust the structure padding, okay, so though it makes your structure performance way better, but now I don't want to adjust this size for performance. Rather, I want to make it more, you know, so for that, we have a keyword. So what is that keyword? We have the keyword as underscore underscore, sorry, is underscore underscore attribute. Here I'll do tagged. Okay, so if I try to compile it again, you will see the structure now has only 5 bytes. Okay, so for the individual structure, we can do like this. So this is applied only for a single structure. If I have multiple structures, so instead of doing in every structure, we can have the pragma back. Then we have push one, and then I can do pragma back pop. So this way also I can make my structure packed 5 same way. Now we understand what is structure padding and why it is used and how to disable this structure padding. So now our next question is why it is required. But the question here is, do we need this optimization everywhere? So the answer is no. So we don't need this optimization everywhere. Okay. So where it is not required or where we are use padding. So the padding is mostly used for packet processing. For example, network kits are going through, through the network to different PC. So if we apply the structured padding, then while reading this network packet, there may be a problem or things may alter. So we don't need any type of structure padding when it is the case of, you know, the network headers, your ELF headers. So where the data is very critical. So rather than optimization, we prefer not to use this optimization for performance. So this padding is good if CPU reads alignment data faster, fewer memory cycles, and better cache uses. Where we do not use structure padding is network packets, most importantly. So if padding happens, the wire formats become wrong at the receiver end. So receiver misreads fields and protocol breaks. So that's why we use packed structure in case of network packets. Second is file formats like ELF headers. If packing on the padding exists, the file size may increase and other programs may fail to parse it. Okay. Shared memory between the different process, that is also a part where we should not use structured padding. Okay. Golden rule is if data stays inside process, then we should allow padding. Okay. So if data stays or process a boundary of a process, then we should remove padding and use backed structures. Okay. So what do you mean by cross boundary? For example, we have network files, we have ELF file headers. Okay, we have shared memory. So these are in IPC's mechanism, inter-process communication. So then we have different architecture. So for example, we have process in a different architecture, then we should not use a pod padding, because if you use padding, the other compiler will interpret it in a wrong way. Okay. So this is all about padding, why it is used. So if you have any query, just post a comment. Thanks for watching my video. See you in the next video. Thanks.